Externality Market Failure, Part 2. With Part 1 video, we learned the definition of externality. We learned about the circumstances we expect to result in a market allocation that will be inefficient. In Part 2, we want to learn why an externality is a source of market failure. Then we will discuss the generic policy by which we think government can correct an externality market failure. We use models of a competitive market to discuss these economic ideas. The first model will be a model of negative externality. Start with a model of a perfectly competitive market. At this point, just notice D for the demand curve and S for the supply curve. I will explain what D and S are equal to in a little bit. Now this could be the market for any good or service. Since we are exploring a negative externality, Q might be kilowatt hours of electricity or perhaps gallons of gas. The market allocation is shown as PE, QE. And of course, this is determined by the intersection of demand and supply. Will the quantity determined by the market, which is QE, be efficient or optimal? The answer is no if there is a negative externality present. A negative externality means there is a marginal external cost that we must now add to the diagram. When marginal external cost is added, we have a line parallel to the supply curve. We are assuming in this case a constant marginal external cost. This means each additional unit of the good produced imposes the same external cost on third parties. The marginal external cost, MEC, is equal to the length of the line segment between points B and C. Now, MPC is the marginal private cost of producing additional units of the good. This is the marginal cost of production for the businesses producing and supplying the good. When there is no negative externality, marginal private cost of production will be equal to marginal social cost, and that happens in a perfectly competitive market model. But when there is a negative externality, the full marginal social cost equals MPC plus MEC, and the marginal social cost will therefore always be above the supply curve in the model of a negative externality. Notice also in this model with a negative externality that demand equals marginal private benefit equals marginal social benefit. This is the situation if there were no externalities, and the presence of a negative externality means the same thing. It only means that the marginal social cost is greater than the marginal private cost. That is, when compared with a model of without a negative externality. Now, we have a model of a negative externality associated with a perfectly competitive market. The optimal quantity of the good is, of course, the quantity at which marginal social benefit equals marginal social cost. This is called point A, and the optimal quantity is shown as Q star. Notice Q star is not the same as QE. So we have the answer to our last question. When there is a negative externality associated with a perfectly competitive market allocation, the market will not achieve the optimal quantity of output. Actually, we see more than this. We can also say that with a negative externality, the perfectly competitive market allocation will produce too much output. In terms of efficiency, The market, in other words, goes too far. It goes beyond the quantity at which net social benefit is maximized. And the area in the triangle ABC shows us the net social benefit lost to the community because the perfectly competitive market fails to produce Q star when there is a negative externality. So, a good way to understand why a negative externality results in a market failure is to say that it results from the fact that buyers and sellers do not see the full marginal social cost of their exchange. The buyers and sellers only see PE. It is often said that there is a divergence between marginal social cost and marginal private cost when there is a negative externality. Now, you might be tempted to say the problem here is that pollution is harming others. Certainly many non-economists would say this. It is very important that you understand this is not the economic efficiency problem. It is not that pollution is harming others. You should notice that even at Q star, the optimal quantity of output, there is still going to be a marginal external cost associated with production and consumption of the good. So the economic efficiency problem is not that there is a marginal external cost associated with the market allocation of this good. The economic efficiency problem is simply that the market allocation is not Q star, it's QE. And again, this happens because buyers and sellers interact with each other without seeing the full marginal social cost of their interactions. When the full marginal social cost is accounted for, in a sense, the interactions between buyers, sellers, and the third parties will be associated with the efficient level of the marginal external cost. In other words, given the presence of a negative externality, the efficient quantity Q star is also associated with an efficient harm, and thus also with an efficient amount of pollution. And in general, at Q star, the efficient quantity of output, this will also be associated with an efficient amount of pollution which is greater than 0. Let's take a look now at the model of a positive externality. I'm going to start with the complete diagram on the model on the right. After showing the construction of the negative externality model, I'm going to assume that I don't need to show the construction of this model. Both models are similar. The difference is that in this model there is a marginal external benefit, MEB, and no marginal external cost. Just like with the negative externality model, we begin by identifying the market allocation. The market allocation is the intersection of demand and supply, and in the diagram, this is identified by point C. The quantity of the good produced and consumed in the market is QE. Is QE the optimal quantity? To answer this question, note that with a positive externality, we have to add a marginal external benefit to the model. We assume a constant marginal external benefit, MEB. The value is given by the distance between points B and C in the diagram. With a positive externality, demand only reflects marginal private benefit, MPB. This marginal private benefit is really what people in the community are willing to pay to obtain another unit of the good. But with a positive externality, another unit of the good also provides a benefit to third parties. So, in the case of a positive externality, the marginal social benefit equals marginal private benefit plus marginal external benefit. The marginal social benefit curve, thus, is above the demand curve in the model. Now we can identify the optimal quantity of the good when there is a positive externality. Like always, the optimal quantity is where marginal social benefit equals marginal social cost. In this diagram, this is identified by point A. The optimal amount of the good is Q star. Notice that QE, the amount the market generates, is not the same as Q star. So we conclude the market allocation will be inefficient if there is a positive externality. And we also notice that if there is a positive externality, the market will produce too little output. A larger quantity, Q star, should be produced from the point of view of efficiency. Look now at the area in the triangle ABC. The area is a dollar measure of how far short the market falls from maximizing net social benefit. We can also say the area in ABC is the potential net social benefit to be gained by correcting the positive externality market failure. Why does the market fail in this case? Once again, it is because the buyers and sellers do not see the full marginal social benefit, in this case, of their exchanges. They only see the price PE. If there is an externality market failure, is there some government action that could correct the market failure? Because the reason for the market failure is that buyers and sellers do not see the marginal external cost or the marginal external benefit, the obvious economic answer to an externality is to find some way to internalize the MEC or the MEB. Internalize means somehow bringing these external values into the market so that these values are seen as part of the social interactions between buyers and sellers. The idea of a corrective tax is the generic economic policy for a negative externality. Take a look once again at the negative externality model. The idea of the corrective tax is to have government impose an excise tax in the market associated with the negative externality. The excise tax would be $T per unit. The value of the $T would be equal to the marginal external cost, or equal to the distance between points B and C in the diagram. If this excise tax is imposed by government, it will cause the market supply curve to shift upward in a parallel fashion by the amount of the distance between B and C. The consequence of this specific excise tax is that the market supply curve now becomes the same as MSC in the diagram. This means that after the tax is imposed, the market equilibrium quantity becomes Q star. Notice there is also an increase in price from PE to P prime. That is, the corrective tax internalizes the marginal external cost, and the market allocation becomes the efficient quantity of output. The market failure is thereby corrected. It is important to note that the revenue from this corrective tax cannot then be used to compensate the third parties. The effect of the tax alone is to achieve efficiency. If the revenue is used to compensate, this will cause another source of inefficiency. One idea in this regard is that if compensation is paid from the corrective tax revenue, one consequence would be, at the margin, some people would, quote, come to the external cost rather than seek to avoid it. At the margin, this would result in an inefficiently large number of people bearing the external cost. Finally, even though we can think of a generic government policy to correct this market failure, as with a public good, we have no clear reason to suppose the incentives faced by those in government will encourage them to try to correct the market failure or to attack this efficiency problem with this policy means rather than some other. And, once again, there would be an information problem to achieve this policy. It is no easy matter to discover what the value of MEC is. Can government correct positive externality market failure? Just as we discussed with a negative externality, we want to look for a way government could cause the marginal external benefit to be internalized. In this case, the government could provide a corrective subsidy. Look again at the relevant externality model on the right. Government could offer an excise subsidy. The subsidy would be $T per unit. The value of the $T would be equal to the marginal external benefit, or the distance between points B and C in the diagram. If this excise subsidy is offered by government, it will cause the market demand curve to shift upward parallel by the amount BC. The consequence of this specific excise subsidy is that the market demand curve now becomes the same as the marginal social benefit curve in the diagram. This means that after the subsidy is offered, the market equilibrium quantity becomes Q star. In this case, there is also an increase in market price from PE to P prime. The corrective subsidy internalizes the marginal external benefit and the market allocation becomes the efficient quantity of output. The market failure is thereby corrected. In this case, the important side note is that the model does not include the source of money by which government pays the subsidy. The money for the subsidy would come out of the government budget, and this means the money is gained through taxation. I say this is a conceptual problem for the model and for the idea that there is a generic government policy to correct the positive externality market failure. The means government uses to gain tax revenue generally cause allocation to be inefficient. In a sense, this model is incomplete. It does, however, suggest to me that even a corrective subsidy may not be a government means to correct a positive externality.